Yesterday, we started talking about function, whether or not something is a function. The big thing we talked about, vertical line test, right? So like we talked here how the vertical line test fails. We talked on the previous one, vertical line test, or just remember your x values cannot repeat. Okay, each x pairs with a unique y. Okay. Then we started talking domain. Okay, domain are my x values. It's how far the graph goes left and how far the graph goes right. And so if you look, I don't think I have that screen up because I was trying to get other classes loaded, but there were kind of 4 things we talked about with domain. Okay, the 2 big things to watch for: is there a square root? And if so, whatever's under the square root has to be positive, so greater than or equal to 0. Or is there a denominator? And if that's the case, denominator cannot equal 0. That can get you an answer, which is basically what we did here yesterday, right? But also then reading the graph left to right. And we'll practice that some too. Remember my suggestion, be able to work them together, hand in hand. Don't just rely on reading the graph. You miss some important concepts there. But I'm not asking you, especially at this level of math, to rely 100% on the equation because I know we're still learning. Okay, so that's why I asked you to work them hand by hand, hand in hand. Okay, so B. Before we left yesterday, I think we mentioned real briefly, what are issues we need to concern ourselves here with if we're talking about domain?
Inside the square has to be greater than 0.
Okay, so we have a radical, like we did last time. Whatever's under a radical has to be positive. Positive in math is greater than or equal to 0. Now, in this particular one, is there any solving to do? No. So right here, what I know is that my graph has to be anywhere x is greater than or equal to 0. We're not going to see my graph exist when x is negative. Okay? So that's part of what I know. Okay, so we're going to hold that thought. What's the other issue we have to be concerned with? Okay, my denominator cannot equal 0. So what we want to do now is we want to find where does the denominator equal 0. Okay, so we just said the denominator cannot equal 0. So what I'm going to do is I'm going to take my denominator and I'm going to set it equal to 0. Because I want to find where are those values that my graph can't exist. Okay? Think basic algebra. How would you like to solve that? Huh? Okay, so one option is add the 25 over. If we add the 25 over, we're going to have x squared equals 25. And then what? Square root. And x is?
Plus or minus 5.
Ah, very good. I need to hear the plus or minus 5, yes? Which, in reality, you'll find out in a moment, it doesn't really matter in this one, but that's the habit we've got to be in, right? We have to think plus or minus 5. Now, does x equal plus or minus 5? No, technically x cannot equal plus or minus 5. Okay? So we kind of have 3 restrictions going on here. X has to be greater than or equal to 0. So x can only be positive. We also know that x cannot equal negative 5, and x cannot equal positive 5. Now, and I'm doing this all without looking at the graph yet, yes? Here's what I'm going to suggest you do. Let's think number line. Okay, and you can visualize this in your head. You don't necessarily have to draw it, but, you know, the teacher in me is going to say, let's draw it. I have 3 key numbers that matter, right? And we're just going to kind of talk our way through this. 0, 5, and negative 5. I put those on there because those are the numbers that matter. So what do we know right now? I'm going to start with the 5s. X cannot equal negative 5 and positive 5, yes? So I'm going to use the old-fashioned method of basically there would be holes at negative 5 or 5. Or negative 5 and 5. Does that make sense? Okay. So like right now, if we don't have any other restrictions, we know that x would be everything except -5 and 5. So it'd be everything to the left, everything in between, everything to the right. But we do have another restriction, don't we? Our other restriction is what? X has to be greater than or equal to 0. So that means what? It's going to be everything to the right of 0. Except, notice what did I do? I skipped 5 because we already know that x cannot equal 5. Okay? If you have a cannot equal something, that trumps a greater than or equal to 0. Okay? And then, if we're thinking interval notation, what would we put at 0? It's greater than or equal to. So, I'm going to think of this as a bracket. Now, again, I still haven't looked at the graph. And I'm going to encourage you to look at the graph before you put final answers down when you're doing this on your own. But without looking at the graph, how do we put this graph here into interval notation? Where does my interval begin? 0. And -5 here. It can't equal -5, but on the flip side, x also can't be negative. So did that even matter? No, that just ends up, that whole section doesn't exist, so, that doesn't really matter anyways. Okay? Now, so we begin at 0. 0 with a bracket, comma. How far do I go?
Infinity.
Not exactly.
You go to 5 and then you go.
We're going to go to 5. What do you think I'm going to put at 5? A parenthesis, because it's 5 included.
Yeah.
Okay, I'm going to think of this as a parenthesis. Okay, I think in my notes I used U for union. And then where?
5.
5 again with a parenthesis. 2.
Infinity.
There's the infinity you wanted. Okay, so the idea is I put an open circle to represent it because I thought that's what would make most sense at that exact moment in your brains. But really, it ends up being parentheses going either way of it. Because the parentheses say we're going up to 4.99999, but we're not including 5. And then on the other side, it's 5.00001, but we're not including 5. Now, I want us to take a look at the graph. So if you haven't already graphed it, or I guess you can always look at my graph. Let's see what this graph looks like. Now, in all honesty, if this is me doing this, do I have to look at the graph? I don't have to look at the graph, folks. I'm done with that problem. Okay? But you guys are beginning this. Okay? You guys are on the opposite end of me. I encourage you to look at the graph. Just don't rely on it. Okay? Fun little graph there. Now you see why we started with the algebra. Okay? Now, does my answer make some logical sense with that graph? Okay? If I like to use my trace button to kind of explore things. If I hit trace, and I arrow, notice that 0, 0 comes up and exists, yes? If I arrow left, what happens? The y value drops off, which means does my graph exist over there? No. And the farther I go left, does my graph exist? No, my y value doesn't exist. So now, okay, you can trace a little bit here. Notice it's existing, and then what's happening? All of a sudden it starts to go down. What isn't really shown very well here, folks, there's a vertical asymptote happening. Okay? Normally the graph would extend more down than that. The calculator does weird things sometimes. This is one of them. But notice, as you arrow right, I'm at 4.69, 4.84. My calculator did pick up 5. Notice what it says. It doesn't exist. Okay? And then if you go to the right of 5, does it exist again? Yeah, it magically hopped up top, which tells you there's a vertical asymptote there. Okay? And then you can arrow to the right and you can see that it continues to exist. Important keys here, folks. In this one, I think you could have figured it out, but could you have figured out that that break isn't exactly at 5? Okay, because that's what once you understand the graphs, yeah, you can maybe just look at that graph, but I don't want you relying just on the graph. Okay, the algebra here is important. Yes?
Why can't you have that positive 5?
Because it would make my denominator 0 here. Because 5 squared would be 25, minus 25, it makes my denominator 0, and we can't divide by 0. If you can do 0 divided by something, but if you try and divide by 0, you're going to get an error. I can't take my 10 cookies and divide them into 0 groups. Okay, we go back to the basic. That's always my example at the high school level is, we take 10 cookies and you try and divide them into 0 groups. I can't. I have to put them at least in 1 group. I can't put them in 0 groups. Okay? So yeah, it's just the fact that it would make my denominator not true. And all these numbers would give me square root of a negative, which would take us into imaginaries. And we're not messing with imaginaries right now. Okay? Other questions I need to respond to?
Oh, that was a little different.
Did you type it in right?
I think I did.
That's going to be my question. That looks right. Okay. Oh, interesting.
So hers kept the.
Yeah, here, I'm going to
Straight
steal
lines
this for a
on
moment.
there.
I don't know why. I like hers better. I made the comment that here at 5, my graphs just kind of went up and down a little bit. That's what I would have preferred that my calculator did. Now, why Jackie's did that and did anyone else's do that? I don't know why yours did that and mine didn't. I don't know if there's some setting different in your calculator or if it's just by chance, because these calculators do weird things at times. Okay? If I see something like that, I know that's a vertical asymptote. Now, that's my experience, and I need you guys to learn, oh yeah, that's a vertical asymptote happening there. Okay? Interesting. Yeah, it's not anything you did other than there could be a difference in setting here somewhere, but I don't even know what setting would make that difference. So I got nothing there, but enjoy. Okay. Anything else? Okay, let's go to the back side. Let's talk a little more domain. A of S equals the square root of 3 over 4 S squared. Thoughts about the domain here? So, we see a square root. We normally talk about having to set it greater than or equal to 0, but what's under the square root? A 3. So does it matter? Okay. When do we worry about the square root having to be positive? If there's a variable of some sort. Okay? So good, that's what we need to talk about. Good. Same thing we could talk about. What about that denominator? It's a number, so does it matter? Okay? Are we seeing what I'm saying here? Okay? When we're talking about the square root must be positive and the denominator can't equal 0, that's when there's variables involved. Square root of 3 over 4 is just a number, it doesn't matter. Okay? So, what's the visual of this graph? What's your brain popping up?
It's like an A, like the number of it's like the A like changes the shape of the parabola.
Okay, there's the word I was looking for. Parabola. Square root of 3 over 4 is the A value, so it's your vertical stretch or compression. That's what you were trying to say. Okay, it'd be a vertical compression. So think with me here. Okay, so there's no square root to worry about. There's no denominator to worry about. This really falls into the category of a polynomial, if you ask me. So what would we say about that? All reals, okay? Now there's a catch. Don't worry, we can't have something this easy on our third example in. Okay? But generally speaking, a parabola, infinitely left, infinitely right, that's that. Okay? So as we look at this equation, if we don't worry about the context of the equation, I'm going to agree that the equation itself represents all reals or negative infinity to positive infinity. Now, the catch they throw in. This is a formula. What does A typically stand for? The capital A out front in formulas.
Area?
Area. This is an area formula. What you guys don't know is this is the area formula for an equilateral triangle. I didn't expect you to know that. Okay? We normally just use 1/2 base times height for a triangle, and that's still valid. But there is a random specific formula for an equilateral triangle, and that's what this is. Okay? So it's the area based on S representing the side length. If we now involve that scenario, does all reals still work? No, because the side of a triangle cannot what? Cannot be negative. So, in this case, what that means is this side is good. This side is not good. Now, am I saying that because of what the formula told me? Or because of what the equation told me? No, I'm saying it because the formula represents area. Am I making sense here? It's a random special case, okay? You look at that equation, I expect you to be able to tell me all reals. Now I say, okay, what if I tell you it's the area of a triangle? Now I expect you to be like, oh, except we can't have a negative side length, so now we have to say it's only the positives. Okay? So I'm going to write out this formula. Models area of a triangle with side S. I'm going to say with side length S. Because of that, what are you going to say about the domain now? This is where you're just using logical thinking.
All real positive.
Okay, all real positive numbers. How would you express that in interval notation?
0 to infinity.
Maybe a parenthesis on the 0, right?
Why am I putting a parenthesis on the 0?
Because your area can't be 0.
Okay. My side length can't be 0, thus my area can't be 0. So that's why I use 0 to infinity, but just with the parenthesis, not equal to 0. Okay? Kind of a catchy one there, isn't it? Now, I'm not even going to pull up the graph of this one, because A, it's a parabola, and B, does that really help me? No, you guys are quite familiar with parabolas. Okay? So we kind of know what we're talking about there. Bless you. Okay, example D. What are you thinking?
The square root. Says
Hmm.
greater than or equal to 0.
X squared plus 5 has to be greater than or equal to 0. Okay? Technically, solve it. What happens when you start solving that?
It's just X squared plus is greater than or equal to 5.
Not 5, but
Nope.
negative 5. X squared has to be greater than or equal to negative 5.
Are you gonna get an imaginary number?
Huh?
Imaginary number?
We're not going to talk imaginaries. Which means, think logically. X squared, I don't care what value x is, what's going to happen when you do x squared? You're going to always get a positive. When I add 5 to it, I'm going to get a bigger positive, yes?
Mm-hmm.
Could x squared plus 5 ever be negative?
No.
No. So, x squared greater than or equal to negative 5, that's guaranteed to happen, isn't it? I don't even have to take the square root here because A, it's going to take us into imaginaries. And that's my red flag that I don't want to talk about imaginaries. X squared is going to be guaranteed to be negative. So this is one of those where, okay, we checked it, it's not going to mean anything to us. Does that make sense? So, I'm going to say this is okay. Already positive because of x squared. Or however you want to write yourself a note that we checked it, but ended up not mattering because x squared plus 5 can't be negative. So there's nothing to worry about there. Okay?
But the bottom would just be x equals 0, which it cannot equal 0.
Okay. So the denominator, we set our denominator equal to 0. My denominator is just x, so there's no solving to do, right?
Right.
So what to realize there is that x cannot equal 0. Now that's valid and important, isn't it? Okay. Anything else? We've checked square roots. We've checked denominators. If I think about this, you guys know what I did earlier. If we think about this like I did 2 problems ago. Okay, the only important number we ended up with was 0, right? If x cannot equal 0, okay, I'm putting like a hole there, like an open circle there. It's kind of my visual. What do you expect? And again, we haven't looked at the graph yet, but what do you expect?
Something like it's close to the x, but won't touch it.
Mm-hmm.
You said something about it earlier, I forget that.
Well, what about a interval notation for this?
Would it just be like negative to close to 0 and then just not touching the 0? I don't know how to say it.
Okay. Help him out, guys. What's he trying to say?
Parentheses, negative, and parentheses 0. Or that's, yeah. And then the union, and then parentheses 0, infinity.
Uh-huh. Okay. So what Brody was trying to say there, it gets really close to 0 but doesn't touch it. In interval notation, I'm going to use parentheses to represent that. Okay. And you could think about, you could put the parentheses on the graph. I was just, Now, if it gets really close to 0 from both sides and doesn't touch it, if I had to guess, it's going to be an asymptote. Okay. That's what most often, not always. If you guys graph this one,
Yeah.
it's x squared plus 25, it's x squared plus 5.
Oh, shoot.
Okay. You have a graph that is visual in quadrants 1 and 3. Yes? Does that make sense? If I hop on the graph from the left, okay, now I'm going back to like algebra 2 methods. If I hop on the graph from the left and I start tracing it, I'm hopping on at negative infinity, and then we start going down. What x value are we approaching as we go down? We're approaching that y-axis of 0. Okay, and then we hop across the asymptote and we're hopping on up here. What are we? We are really close to 0, right? And you're going 0 to infinity. Okay? Okay, guys. Those are domain examples. Every problem's a little different. You just have to get in and experience them. My recommendation is not just to rely on algebra and not just to rely on the graph, but try and use the knowledge of them together. Okay? I know I've kind of pretty much shown them without the graph, almost. But that's because I really need you guys to work on the algebra. Okay? I do expect you guys looking at the graphs. Okay? But just don't, I do not encourage you to only use the graphs. That's where we run into problems. Okay? Okay, questions on that one? Okay, let's talk a little range. Okay, I think in homework you have 4, are they functions? That's not right. 2 domain and 2 range. Maybe it's 3 functions, 3 domain, 2 range. I don't know. That doesn't even add up, right? So who knows? You have a little bit of each. You have some functions, you have some domain, you have some range. Okay. Now, range. Couple of things. Same rules apply to range as they do for domain. Only, officially, you have to solve for x first. Okay? And then when we talk about reading the graph, we'll read the graph from bottom to top. Okay? So, I'll be honest. When it comes to range, for the most part, we're going to focus on reading the graph. But on this first one, I'm going to kind of show you an option. It just doesn't always work easily. Okay? So when we are talking domain, the equations were y equals, and it's, okay, what are the x's doing? Oh, we can't have an x in the denominator. It can't be under the radical, those type of things. Well, now when we talk range, it's what is the y doing? Okay? I don't care about the x anymore. I care about the y. So one option is to solve for x first. So, okay, we all know f of x is a fancy name for
1.
So this equation is really y equals 2 over x. Solve this equation for x with me. If I solve this equation for x, how do I get x by itself? First of all, we're going to multiply that x over, aren't we? Because we want to get out of the denominator. So then I end up with x times y, so xy equals 2 because my x's cancel. And now how do we, I want to solve for y, I don't have it. How do we solve for x? Divide by y. And we have x equals 2 divided by y. Okay, guys. Our domain rules about denominators and radicals. Apply those. Now that you have it x equals, apply those, but apply them to y. What do we know?
Set y equals 0, it cannot equal 0.
Okay. We have y in the denominator. The denominator can never equal 0, so we know that y will not be able to be equal to 0. Okay. No radicals, yes? Let's check out the graph. Okay. And as I said, guys, and you'll notice real quick, we can't always do this solving technique, but what we can always use is the graph. Now, when I graph this, my graph is set for y equals, right? So I'm graphing 2 over x, right? It almost looks like the same exact graph of what I just did. Okay. This is range. Range is in terms of y values. I'm not reading left to right now. I'm reading
Bottom to top.
bottom to top, right? I know I want to say up to down, up down also, but bottom to top is what I'm trying to say. So if I'm reading bottom to top, how low does my graph go? Negative infinity. It's going up, it's going up. As it goes up, it starts caking off to the left. What value is that approaching? What y value is that approaching as it's going off to the left?
0.
It's approaching 0. Because what do we see happening at 0? It looks like a
Straight line. Parallel asymptote.
asymptote.
Oh, asymptote.
It's a straight line that's acting
I
as
see what
a
you're saying.
horizontal asymptote. That's the vocab word I was looking.
Yeah.
So okay, so it's going to get close to 0, but is it going to touch it? No. Then after it gets as close as it can on the left, we're going to flip up above, and we're on the right side. So now what are we doing?
Start at 0.
Yeah, we're coming from the right, and we're as close to 0 as we can get as we approach up. What's that going to make my range here?
Parentheses, negative infinity, comma, 0, parentheses, with the u, parentheses, 0, and then comma, infinity, parentheses.
Kind of like our last range, yes?
Yeah.
Okay. Coincidence there. But this is reading your graph from bottom to top. Okay? This time, you're reading your graph from bottom to top. So, okay, as we hop on at the bottom, it's coming from negative infinity. It's getting closer. As it's going off left, it's getting closer and closer to 0. Hops here, 0, up to infinity. Okay? Now, that one, it kind of gave us a clue here. Yes? Could you have done that without the solving and just looking at the graph? I could have. Are you getting to that point? Okay. I'm going to force you to get to that point real quick. How do you feel about solving equation B for x?
Do we have to do anything with x? Like,
It's going to be real difficult to solve for x, is what I'm going to say. I'm not going to say it's not possible. However, it's more than I want to attack. So, if I can't solve this for x, that means I can't do the, okay, any denominators, any square root business, because I need to talk about y's. So what are we going to jump straight to? Graph it. Okay? And here's what I'm going to tell you. That's going to happen more often than not on the range. On the range, more often than not, jump to the graph. Okay? Brody apparently does not like the graph.
it looks like this graph to be a face. It is.
Oh, that's a face to Brody, so.
My shy guy.
Now, I'm putting a graph on mine just to have a visual. Oh, shoot. Okay. range. How do we read range?
From bottom to top.
Okay. We're going to read bottom to top. How low do we go?
Negative infinity.
Easy enough? Okay. Going down here at the bottom represents negative infinity. Now, okay, so hop on either side of the down low, right? We're going up, we're going up, we're going up, we're going up. What do you notice?
0.
That upside down parabola looks like it comes to a stop at 0. Do you know that for sure?
No.
Can we figure it out for sure?
Yeah. Using
You can.
Z box.
Well, I wouldn't even do that. Honestly, I would just hit trace. And ironically, it puts you right there. It tells me that point right there is 0, 0. So can I feel confident that it goes up to 0?
Yeah.
Okay. So this graph goes as low as negative infinity. And then this portion of the graph goes to 0. Okay, so that's part of my range. Part of my range is negative infinity, which always uses parentheses, to 0. What do you want? Bracket. Did it touch y equals 0?
Yes.
Yes.
Yes, when I hit trace, it's touching y equals 0, so that's a bracket. Now, union. Now what's my graph do?
Starts at 0.
No.
Like it never touched.
Okay.
It starts somewhere,
Like your asymptote just
and we can see a horizontal asymptote going there, yes? The big question becomes, where is that horizontal asymptote? Is it 0? Is it 1? Is it some other random fraction or decimal? Okay. Now, how do we decide?
Just trace.
I traced it and it just.
Okay, and that's, okay, so get in trace, okay, and it doesn't matter really if you take off left or right. I'm going to take off to the right. And as I do that, it pops me up top. We're trying to find range. Watch your y value. And the farther I go, it'll move my graph off to the right. I'm at 1.002. 1.001. They've thrown some random fractions there.
Getting closer.
It's like you can keep going forever.
Okay, I'm at 1.0008, I think now. Here's the deal, guys. If I was going to cross past 1, it would have long since happened. Okay? Does that make sense?
Yeah.
We wouldn't be going that far and still stuck at 1 if we were going to cross past 1. That's the best way I can suggest to figure this out. Does that make sense? Now, with that in mind, we will eventually review, it comes up in later on, lesson 1.2, horizontal asymptote rules. If the powers are the same, top and bottom, you use the coefficients. The coefficients are 1. Guess what? There's a horizontal asymptote at 1. We'll review that. Don't worry. Don't stress about that. So, this right here, there's a horizontal asymptote happening at 1. So now, what are we thinking here? What's the second part of my range? Do we agree with parenthesis? It's an asymptote, so is it technically going to touch 1?
No.
No. So parenthesis 1 to where?
Infinity.
Up to infinity. Okay. There's your real lesson on reading a graph today. Okay. You just have to play around. Don't just guess. Okay. Was Brody's guess of 0 logical? It was, because what did we kind of expect to see? It is. Play around with the calculator some to figure that out, though. Okay. And here's my other thing. Here's the reason me as the math teacher could say I know it's not 0. This parabola touched 0. So I know it can't be an asymptote. Well, I guess technically it could, because asymptotes horizontal is in behavior, but that would just be, it would have been weird that way. Okay? And so, okay, guys, you have 2 through 20 evens. It's 10 questions. Put some thought into them, okay? Now, are there going to be questions tomorrow? There's going to be questions. It's one of those homeworks, okay? I expect some questions. Okay? But I also need you, don't just kind of try and, oh, only 10 questions. I'll just breeze through these in a couple of minutes. Sit down and take a few minutes and put some thought into them. Make sense?
Yeah.
Okay? And we will definitely discuss tomorrow.